Now in the next example, we are again taking an example of a projectile. A gun kept on the horizontal road is used to hit a car traveling along the same road away from the gun with a uniform speed of 72 kilometers per hour. Now this 72 kilometers per hour must be converted to meters per second. So there is a fraction 5 over 18. We multiply 72 kilometers per hour with 5 over 18. So 72 will be cancelled with 18 and the net result will become 20 meters per second. So 72 kilometers per hour will be 20 meters per second. The car is at a distance of 500 meters from the gun. When the gun is fired at an angle of 45 degrees with the horizontal, then we have to find these events. The distance of the car from the gun when the shell hits it. Another thing we have to find the speed of projection of shell from the gun when g is 9.8 meters per second square. Now, in the solution, we will see the speed of the car is 72. We have converted this speed into meters per second by using the multiple 5 over 80. If there is miles per hour, then we use another equation that is 22 over 15. So, or otherwise, in meters per second, the kilometers per hour are multiplied by 5 over 18 and our result will become 20 meters per second. The time of flight of projectile that is assumed to be t and it is given by formula 2u sine theta over g. Now u is kept as it is and for theta we have put 45 degrees. Sine 45 degrees will be 1 over root. We rationalize root 2 and our result will become u root 2 over g. U root 2 over g. As theta is 45 degrees, we mark it as equation number 1. Now the range of projection that is given by formula u square sine 2 theta over g. This is the formula for range, horizontal range. Now u square over g is written as it is and sine 2 theta, that is sine 2 multiplied 45, that is sine 90 and sine 90 will be 1. So our equation will become u square over g. This is marked as equation number 2. Now according to the given problem, range is 500 plus Vt. That is the statement of the question. Substituting the values of t and r from equation 1 and 2 in the above equation, so we will get u square over g is equal to 500 plus u root 2 divided by g multiplied 20. So in the figure it is shown angle of projection 45 degrees and the car is moving on the horizontal and the distance moved by the car on the horizontal is supposed to be the range and that range r is equal to totally 500 plus Vt. So we have taken from equation 1 and 2 that is 500 plus and then we have added t there and it will be u root 2 over g multiplied 20. Now the equation is made that is u square minus 20 root 2 u minus 4900 equal to 0. This is quadratic equation in u and u is the initial velocity of projection. So from the quadratic equation, we will use the formula minus b plus minus under root b square minus 4ac over 2a. By using this formula, we get the value of u. And after getting the value of u, there will be two values of u in the quadratic equation. The negative value is not taken into consideration and the positive value will be u is equal to 10 into 1.414 plus 7.141 and that this becomes 85.56 meters per second. Substituting the above value of u in equation number 2 and from that we will get the value of range which is u square over g. So for u we will compute the value in squares 85.56 square divided by 9.8. If the value of g is not given, we can accept the value as 10. However, here it is 9.8 and the net result of the range will be 746.9 meters. So it is shown in the figure 500 plus Vt and that is calculated as the horizontal range, that is 746.9 meters. Now in another example, a person observes a bird on the tree 39.6 meters high. So the height of the tree is given to us and at a distance of 59.2 meters. With what velocity the person should throw an arrow at an angle of 45 degrees so that it may hit the bird. According to question, height is 39.6 meters, angle of projection 45 degrees, and the distance of bird from the observer 59.2 meters. Now here we will make certain assumptions. U meters per second is the initial velocity of the arrow and it hit the bird after t seconds. The horizontal component of the velocity is given as u cos theta. Here it is taken as u cos 45 degrees and cos 45 degrees is 1 over root 2. So we have calculated the value as u over under root 2. Hence, the horizontal distance traveled in t seconds is, that is, distance is velocity into time. So it is u over under root 2 multiplied t. That is found to be 59.2. This is marked as equation number 1. The vertical distance traveled in t seconds is given in our question. It is 39.6 meters. The acceleration, that is acceleration due to gravities, for the vertical distance we are taking the value of g. It is taken as minus 9.8 meters per second square. And initial vertical velocity will be u sine theta. Theta is 45 degrees. So it is u sine 45 and sine 45 is 1 over under root 2. The net value will become u over under root 2. Therefore, the formula for the height will be ut plus half gt square. So we will compute the values. So we have height as 39.6 meters given in the question. Then ut, u is taken as u over root 2 as we have calculated earlier multiplied by t minus half gt square. However, it is positive but g is negative. So we have taken a negative sign. Half g into t square. This is equation 2. We simplify this equation and it will become quadratic in time t. So equation 1 and 2, we get 39.6 is equal to 59.2 minus 1.2, 1 over 2 into 9.8 t square. From this equation, make the subject of equation as t square. So t square after the transformation is calculated as t is equal to 2 seconds. So it will be basically t square is 4. We have taken the square root. So t is equal to 2 seconds. Now substituting this value of t in equation number 1, we get u over root 2 multiplied 2, that is 59.2. So u is equal to 29.6 under root 2 meters per second. If we wanted to find the exact value, root 2 can be taken as 1.414 and we can multiply the number by 29.6 and we can reduce our value up to 2 decimal places.